There are several possible reasons an electrician may decide to run a dedicated circuit for a ground fault circuit interrupter (GFCI) outlet in a bathroom. Firstly, code requirements may mandate dedicated circuits for GFCIs in some jurisdictions to enhance safety. This is because GFCIs are critical safety devices, and ensuring they have a dedicated power source minimizes the risk of them being affected by other appliances or devices in the same circuit. Secondly, circuit capacity may be a concern. The existing light and exhaust fan circuit might already be nearing its maximum load capacity. Adding a GFCI, especially if other devices are plugged into it, could overload the circuit, posing a fire hazard. Electrical codes specify the maximum load allowed on a circuit, and the electrician must ensure compliance. Thirdly, circuit protection is another factor. A dedicated circuit typically has a smaller circuit breaker or fuse. This provides more sensitive and faster protection specifically for the GFCI. In the event of a fault within the GFCI or any device plugged into it, the dedicated breaker will trip more readily, minimizing the risk of electrical shock or fire. Fourthly, future expansion is often considered. A dedicated circuit for the GFCI provides flexibility for adding other devices in a bathroom later, such as additional outlets, air dryers, or other appliances. This prevents the need for rewiring or overloading existing circuits in the future. Instead of running a dedicated circuit, there are alternatives that the electrician could have considered. One alternative is to use a different circuit. If there is another existing circuit in a bathroom or nearby that has sufficient capacity and is not heavily loaded, the electrician could potentially tap into that circuit to power the GFCI. However, this would require careful assessment to ensure the circuit can handle the additional load safely. Another alternative is to install a subpanel. A subpanel is a smaller electrical panel that is fed from the main electrical panel. Installing a subpanel in a bathroom would create a dedicated circuit for the GFCI without having to run a long Harman wire all the way back to the main panel. This can be a more cost-effective solution, especially if the main panel is far away. And finally, the electrician could replace the existing light and fan circuit. If the current circuit is indeed overloaded or close to being overloaded, the electrician could replace it with a higher capacity circuit. This would involve using thicker gauge wires and a higher amperage circuit breaker to safely support all the devices, including the GFCI. It is important to consider a number of electrical code requirements. The National Electrical Code, NEC, and local electrical codes dictate the requirements for bathroom circuits. These codes address the number of outlets required, GFCI protection, and allowable loads on circuits. The electricians must adhere to these codes to ensure safety and compliance. The NEC requires GFCI protection for all receptacles in bathrooms. This is to protect against electrical shock hazards in damp environments. The NEC also specifies that bathroom circuits should be 20 amp circuits to handle the load of hair dryers and other appliances. Before doing electrical work, determine the circuit load calculation. Electricians perform load calculations to determine the total amperage draw on a circuit. This involves adding up the wattage of all devices connected to the circuit and converting it to amps. The total load must not exceed 80% of the circuit breaker's rating to prevent overloading. To calculate the load, first determine the wattage of each device. Then add up the total wattage of all devices on the circuit. And finally, divide the total wattage by the voltage of the circuit, typically 120 volts, to get the amperage. Understanding circuit breakers and fuses is also important. Circuit breakers and fuses are safety devices that protect electrical circuits from overcurrents. They are designed to trip or blow when the current exceeds the circuit's capacity, preventing overheating and fires. Circuit breakers can be reset, while fuses must be replaced. Selecting the correct size circuit breaker or fuse for a circuit is crucial for safety. A breaker that is too small will trip frequently, while a breaker that is too large will not provide adequate protection. There are different types of electrical wiring. Common types of electrical wiring used in homes include non-metallic (NM) cable, also known as Romex, and flexible metal conduit (FMC). NM cable is typically used for general purpose wiring, while FMC is often used for exposed wiring or in areas where protection from physical damage is needed. A gauge of the wire determines its current carrying capacity. Thicker wires can carry more current safely. Electrical codes specify the minimum wire gauge required for different amperage circuits. Working with electricity can be dangerous, so it is important to take precautions. Always turn off the power to the circuit you are working on at the circuit breaker before starting any work. Use insulated tools and wear appropriate safety gear such as safety glasses and gloves. If you are not comfortable working with electricity, hire a qualified electrician. When troubleshooting electrical problems, start by checking the circuit breaker. If the breaker has tripped, reset it. If the breaker trips repeatedly, there may be a short circuit or overload on the circuit. Use a multimeter to test for voltage and continuity. This can help you identify the source of the problem. Also inspect wiring for damage or loose connections. This can cause electrical problems and should be repaired promptly. If you are unsure about how to troubleshoot an electrical problem, consult with a qualified electrician. There are many different types of electrical outlets, including standard outlets, GFCI outlets, and arc fault circuit interrupter (GFCI) outlets. Standard outlets are used for general-purpose applications. GFCI outlets are used in bathrooms, kitchens, and other damp locations to protect against electrical shock. SI outlets are used to protect against arc faults, which can cause fires. When installing electrical outlets, follow the manufacturer's instructions and electrical codes. Make sure the outlet is properly grounded and that all connections are tight. Use wire connectors to join wires together and wrap electrical tape around the connections for added insulation. There are various types of lighting fixtures. Common types of lighting fixtures include incandescent lights, fluorescent lights, and LED lights. Incandescent lights are the least energy efficient, while LED lights are the most energy efficient. When choosing lighting fixtures, consider the brightness, color temperature, and energy efficiency. Install lighting fixtures according to the manufacturer's instructions and electrical codes. Make sure the fixture is properly grounded and that all connections are tight. Use wire connectors to join wires together and wrap electrical tape around the connections for added insulation. Grounding is an important safety feature in electrical systems. Grounding provides a path for fault current to flow back to the source, causing the circuit breaker to trip and energize the circuit. This protects against electrical shock hazards. All electrical outlets and appliances should be properly grounded. Check the grounding system periodically to ensure it is working properly. There are building codes and permits that must be followed. Electrical work is subject to building codes and regulations. Before starting any electrical work, check with your local building department to see if you need a permit. Permits ensure that the work is done safely and in accordance with code. Inspections are typically required after the work is completed. When selecting an electrician, check their qualifications and experience. Make sure they are licensed and insured. Ask for references and check online reviews. Get multiple quotes before hiring an electrician. A qualified electrician can ensure that the electrical work is done safely and correctly. They can also help you troubleshoot electrical problems and provide advice on energy efficiency. There are many resources available to learn more about electrical safety and wiring. Local community colleges and trade schools offer electrical training programs. Online resources such as the National Electrical Code website and the Electrical Safety Foundation International website provide valuable information. Electrical safety is essential for protecting yourself and your family from electrical hazards. By following safe practices and consulting with qualified professionals, you can ensure that your electrical system is safe and reliable. Understanding voltage drop is also crucial in electrical circuits. Voltage drop occurs when the voltage at the end of a long wire run is less than the voltage at the source. This can cause appliances to malfunction or not work at all. To minimize voltage drop, use thicker gauge wires and keep wire runs as short as possible. Electrical codes specify the maximum allowable voltage drop in circuits. When installing electrical appliances, follow the manufacturer's instructions and electrical codes. Make sure the appliance is properly grounded and that all connections are tight. Use the correct size circuit breaker and wiring for the appliance. Do not overload circuits by plugging too many appliances into one outlet. Electrical panels, also known as breaker boxes, distribute electricity throughout a building. They contain circuit breakers that protect individual circuits from overcurrents. Electrical panels should be properly labeled to identify the circuits they control. Keep the electrical panel accessible and free from obstructions. Periodically inspect the electrical panel for signs of damage or corrosion. Surge protection is important for protecting electronic devices from voltage spikes. Voltage spikes can damage sensitive electronic equipment, such as computers, televisions, and appliances. Surge protectors divert excess voltage away from the devices, preventing damage. Use surge protectors on all electronic devices, especially those that are expensive or critical. There are whole house surge protectors that can be installed at the electrical panel to protect all of the circuits in the building. Arc fault circuit interrupters of size are designed to protect against arc faults, which are dangerous electrical conditions that can cause fires. Size detect arc faults and quickly shut off the power to the circuit, preventing a fire. Size are required in many areas of the home, including bedrooms and living rooms. Tamper-resistant receptacles, TRRs, are designed to prevent children from inserting objects into electrical outlets. TRR have spring-loaded shutters that prevent access to the electrical contacts unless a plug is inserted. TRR are required in many areas of the home, including bedrooms and playrooms. Smoke detectors are essential safety devices that detect smoke and warn occupants of a fire. Smoke detectors should be installed on every level of the home and in each bedroom. Test smoke detectors monthly to ensure they are working properly. Replace smoke detector batteries at least once a year. Carbon monoxide detectors are also important safety devices that detect carbon monoxide, a colorless and odorless gas that can be deadly. Carbon monoxide detectors should be installed near sleeping areas. Test carbon monoxide detectors monthly to ensure they are working properly. Replace carbon monoxide detector batteries at least once a year. And finally, be aware of electric shock hazards. Electricity can be deadly. Avoid contact with electrical wires and equipment. Never use electrical appliances near water. If you experience an electrical shock, seek medical attention immediately. It is important to prioritize electrical safety and to follow safe practices when working with electricity. This helps protect oneself and others from electrical hazards. When an electrician suggests a dedicated circuit for a GFCI, it's important to consider the reasons carefully. While it might seem like an unnecessary expense, there are often valid safety and code compliance reasons for the recommendation. Discussing the matter further with the electrician, understanding the specific rationale, and exploring alternative solutions, if feasible, are all advisable steps.